Hello students, you are welcome to Popular E-Learning Center. Today we are going to look at elective mathematics indices for SHS 1. So we are continuing from where we end the last time. I'm your facilitator, Guamano Kingsley. Below is my WhatsApp contact number. So if you have any problem, you can just send me a WhatsApp message and we discuss it and talk about it. Fine. By the end of this lesson, we want students to be able to use the laws to prove these properties. First, we want to prove the property that in the bracket a over b all raised to power n is equal to a raised to power n over b raised to power n. Also, we want in the bracket a times b raised to power n to be the same as a raised to power n times b raised to power n. And also we want to prove that a raised to power 0 is equal to that any number raised to power 0 is equal to 1. And also 1 over a raised to power n is the same as a raised to power negative n. And lastly, we want to also look at a over b all raised to power negative n is the same as b over a all raised to power n. Before we continue, let's look at last time the exercise that we were supposed to do or try at your leisure time. Let's see how we were supposed to answer that questions. First, we were given this question and we wanted to solve and leave our answer in the index form. First, from the third law, we see that 5 raised to power 3 all raised to power 3 can be written as 3 times 3, which is 5 raised to power 9. And if you have 2 raised to power 4 times 2 raised to power 5, because the bases are the same, you can add the exponents and get 2 raised to power 9. When you come to the denominator, you have 5 raised to power 4 times. See that 2 raised to power negative 3 all raised to power 4. You go to that, you can multiply the negative 3 and therefore to get negative 12. So in all, you see that you have 5 raised to power 9 times 2 raised to power 9 all over 5 raised to power 4 times 2 raised to power negative 12. And we're supposed to work this. So we see that the 5 raised to power 9 and 5 raised to power, the bases are the same, they are divided. And when they are divided, we subtract the exponents. So it becomes 9 minus 4, that is giving me 5. And the 2 raised to power 9 and the 2 raised to power minus 12, they are also divided. So we subtract the exponents. That will give me 9 minus 12. That will give you 9 plus 12, that will give you 21. So we are expected to get 5 raised to power 5 times 2 raised to power 21. I hope you got it right. If you got it right, then clap for yourself. Let's go to the second one. For the second question, we also have 3 raised to power 3 times 3 raised to power 2 all raised to power negative 3 times 7 raised to power 4 all over 7 raised to power 2 times 3 raised to power 2 all raised to power 2. So you use the third law over here. So you multiply the 2 and negative 3 to get negative 6. So at the numerator we get 3 raised to power 3 times 3 raised to power negative 6 times 7 raised to power 4 all over 7 raised to power 2, and then we multiply these 2 and these 2 using the third law to get 3 raised to power 4. Then you see that we have 3 raised to power 3 times 3 raised to negative 6. We are multiplying, so we add the exponents. So 3 minus 6 will give me negative 3. But we have 3 raised to power 4, which is also divided. So that one we subtract the exponent. So in all, we are going to get 3 minus 6 plus 3. That's going to give me negative 7. That's why I have 3 negative 7 over here. And then you have 7 raised to power 4, so dividing 7 raised to power 2. So you have 4 minus 2, that will give me 7 raised to power 2. So we are supposed to get 3 raised to power negative 7 times 7 raised to power 2. I hope you got it right. The last question. We are also supposed to solve this. The same idea. Using the third law, 3 raised to power minus 2 raised to power 6 is the same as 3 raised to power minus 12. 6 raised to power minus 3 all raised to power 2 is the same as 6 raised to power negative 6, because you multiply negative 3 and 2. And then we decide to multiply those with the same exponents, with the same bases. So if you look at the 3 raised to power minus 12 times 3 raised to power 5, so you have minus 5 plus 5 minus 4, because 3 raised to power 4 is divided. So minus 12 plus 5 minus 4, you get minus 11. Then 6 raised to power 15 minus 6. That will give me 15 plus 6. That also give me 21. So in what we have 6 raised to power 21 times 3 raised to power negative 11. That is the work that we were supposed to do the other time. Thank you. I hope you all got it right, students. So let's move on to today's work. Fine. Let's look at this. We have 2 raised to power 3, 2 over 3, all raised to power 4. We got to know that 2 raised to power 3, all raised to power 4, it means that we are multiplying 2 raised to power 3 how many times? 4 times. So it is 2 raised to power 3 times 2 raised to power 3 times 2 raised to power 3. And you know that for multiplication, we can multiply numerators and then multiply denominators. So when you look at the numerators, how many times are you multiplying the 2? So we are multiplying the 2, 1, 2, 3, 4. So it means that 2 raised to power 4. Then when it comes to denominators, how many times are we multiplying the 3? You are multiplying it 3 times. So it's the same as 3 raised to power 4. So when you come, you see that 2 raised to power 2 over 3, all raised to power 4, is the same as 2 raised to power 4, 3 raised to power 4. Let's look at the second illustration. I have 5 over 7, all raised to power 5. So I multiply 5 over 7 5 times. So 5 over 7 times 5 over 7 times 5 over 7, 5 of them. So as I said, first you multiply numerators and can multiply denominators. So you have 5 times 5 times 5 times 5 times, which is the same as 5 raised to power 5. And you have 7 times 7 times 7, which is the same as 7 raised to power 5. What do you see? So you see that 5 over 7, all raised to power 5, is the same as 5 raised to power 5, 7 raised to power 5. So in conclusion, we can say that when you have a over b, all raised to power n, then it is the same as a raised to power n, b raised to power n. I hope it is understood. Let's go through the next illustration over here. We have 2 times 3, all raised to power 4. The 2 times 3 is raised to power 4. So this means that 2 times 3 times 2 times 3 times 2 times 3 times 2 times 3, 4 of them. So what do you see? You see that we are multiplying the 2. If you take the bracket out, we are multiplying the 2 how many times? 1, 2, 3, 4. Which is the same as 2 raised to power 4. And we are multiplying the 3 to how many times? 1, 2, 3, 4. Which is 3 raised to power 4. So we are saying that 2 over 3, all raised to power, the bracket all raised to power 4, is the same as this 2 raised to power 4. This 3 also raised to power 4. Let's come to the second illustration. 5 times 7 raised to power 3. So 5 times 7 times itself 3 times. So 5 times 7, 5 times 7, 5 times. So we are multiplying it 3 times. So in the same thing, you see that the 5 is multiplying itself how many times? 1, 2, 3. Which is the same as 5 raised to power 3. The 7 2 is multiplying itself how many times? 3. 1, 2, 3. Which is 7 raised to power 3. So what do you see? So you see that 5 raised to power 3 times 7, 5 times 7 all raised to power 3 is the same as 5 raised to power 3, 7 raised to power 3. So what is the conclusion? So we can conclude that if I have a times b all raised to power n, then it is the same as a raised to power n times b raised to power n. I hope this property too is understood. Thank you. So let's move on. Let's look at another illustration also to prove another property over here. Fine. We have 5 raised to power 6 divided by 5 raised to power 6. You know what is 5 raised to power 6? You have multiplied 5 6 times. So 5 times 5 times 5 times 5, 6 times. Over, division is over. So 5 times 5 times 5 times 5 times 5, 6 times. So in a normal cancellations, 6 of this, 6 of this, we can cancel. My answer will be 1. But from the laws, we got to know that if I'm doing division, division means subtraction. So I'm subtracting the exponent. So this is 5, 6 minus 6, that will give me 5 raised to power 0. So this and this are the same. So we can conclude that 5 raised to power 0 is equal to 1. Let's come to the second illustration 2 over here. I have 7 raised to power 3 divided by 7 raised to power 3. The same way, 7 times 7 times 7, that's the 7 raised to power 3, divided by 7 times 7 times 7. The normal divisions, we do cancellations, and then we get the answer to be 1. So when you go to our laws, we got to know that when there is division, you subtract the exponents when the bases are the same. So this becomes 7 raised to power 3 minus 3. 3 minus 3 is 0. So we say 7 raised to power 0 is also equal to 1. So we can conclude that anything that raised to power 0 is also equal to 1 from the properties. Sorry. Thank you. We are now still on the property. We want to know more of the properties, using what we know, the laws, to prove more of the properties. First, let's also look at this one. 5 raised to power 2 divided by 5 raised to power 5. The same division. Let's go. 5 raised to power 2, it means 5 times 2. 5 times 5, sorry. Then 5 raised to power 5, then we have multiplied 5 times. Let's do the normal cancellations over here. 2 of the 5 will cancel 2 of the 5s over here. So I'll be left with 1 over 5 times 5 times 5. So 5 times 5 times 5 is what? 5 raised to power 3. So this is the same as 1 over 5 raised to power 3. Let's go back to our laws. We got to know that when it was division, it's division, and the bases are the same, you subtract the exponents. So we are going to have 2 minus 5. And 2 minus 5 is what? Minus 3. But we are saying this and this are the same. So here you can conclude that 1 over 5 raised to power 3 is the same as 5 raised to power negative 3. What do you see? You see that this was a denominator, but now it has become a numerator, and the exponent has done what? Changed. Let's come to the second illustration. I have 7 raised to power 4 divided by 7 raised to power 6. So let's also do this. This is the same as 7 is multiplying itself 7 times, divided by 7 is multiplying itself 6 times. So 4 of the 7s over here will take care of the 4 of the 7s over here. So I will left with only 2 of the 7. So I'll get 1 over 7 times 7. Note that 7 times 7 is the same as 7 raised to power 2. Good. Now let's go to our laws. The law says that when it is division and the bases are the same, you subtract the exponents. So here we are going to have 4 minus 6. 7 raised to power 4 minus 6. And what is 4 minus 6? It's the same as negative 2. So what's the conclusion? The conclusion is that 1 over 7 raised to power 2 is the same as 7 raised to power negative 2. So how do you do the conclusion here? So we are saying that if I have 1 over a raised to power n, the moment the denominator becomes a numerator, then the exponent, the sign of the exponent should change by our illustrations over here. I hope it's understood. Thank you. Now, let's prove this also from just the one that we just said. We say that 1 over a raised to power n is the same as a raised to power negative n. See, when the value changes, when the position changes, when it's a denominator and it becomes a numerator, the sign of the exponent will change from just ended property. So just let's want to use that over here. A over b all raised to power n, you've got to know that this is the same as a raised to power negative n all over b raised to power negative n. So this is negative and this is negative. One thing is, with that calculator, it is very difficult to find a root of a negative number. So normally when the root is a negative, you try to make it positive. So this is negative. So we got to know that the moment the position changes, if it is a numerator and it becomes a denominator, the exponent, the sign of the exponent will change. So the moment this is a numerator, the moment it becomes a denominator, the sign will do what? Change. And the moment this is a denominator, the moment it becomes a numerator, the sign also will do what? The exponent sign will do what? Change. And we got to know that b raised to power n all over a raised to power n is the same as b over a all raised to power n. So these are the properties that I want us to know today. Then you have to also know this thing. Nth root of a is equal to the same as a raised to power 1 over n. So if I have square root of 4, it's the same as 4 raised to power 1 over 2. If I have third root of a, it's the same as 1 over a raised to power 1 over 3. If I have fourth root of 5, it's the same as 5 raised to power 1 over 4. Okay, I want us to use the properties that we have just gone through to solve these questions. Let me give you just a minute for you to go through this and see how you can solve this before I go on to the solutions. So I'm just giving you a minute for you to go through yourself and see how to solve it. I hope by now everybody has finished number 1. So let's look at number 1. Okay. For the number 1, first, as I told you, it is very difficult to solve any problem with negative exponent. So the first thing that you have to do is you have to make it a positive exponent. So what do? Just end the property. Say the moment that this thing changes, the position changes. If a numerator becomes a denominator, the exponent sign will change. So when you reciprocate this one, it becomes 27 over 8. The 27, which is a numerator, denominator is not a numerator. The 8, which is a numerator, is not a denominator. So the sign will do what? Change. So I'm going to have 27 over 8 all raised to power 3. That's the first point that you have to know. Now, this is 27. You know that 27 is the same as 3 raised to power 3. And 8 is 2 raised to power 3. That is, I've simplified the 27 and the 28. I want to use the last law, the last time that we meet. And we know that when you have this is the same as this times this times this. Because this is the same as 3 over 2 all raised to power 3. Because you have a over b. We know that when you have a over b all raised to power n, the same as a raised to power n over b raised to power n. So if I have 3 raised to power 3 over 2 raised to power 3, so this one too is the same as 3 over 2 all raised to power 3. That is what I have over here. 3 over 2 all raised to power 3. So you work out this one and this one. So this 3 will cancel this 3. And you have 3 over 2 all raised to power 2. So we know that this is the same as 3 raised to power 2, 2 raised to power 2. And I'll get my answer to be 9 out of 4. So that is the first one. Let's also look at the second one. What I decided to do with the second one is also I want to change all the exponents which are negative to positive. Because this type of question, mind you, we are not supposed to use calculator. The moment the examiner sees that you are using calculator, you get 0. So be very, very careful. Fine. So first, I'll change all the negative exponents to positive exponents. What's the negative exponent over here? See that the 16 raised to power negative 3 over 4. The moment this 16 becomes a denominator, the sign will change to positive. So that is what I have done over here. So see, I maintain this one because it's a positive, it's still there. This one comes down to be a denominator because I want the sign to change to positive. This one is positive, so I maintain it over there. Good. So I'm going to the third law, using the third law over here. What is 81? It's the same as 3 raised to power 4. What is 116? Is the same as 2 raised to power 4. What is 32? Is the same as 2 raised to power 5. So you see that this is the same as 4 times 1 over 4, 4 times 3 over 4, and 5 times 1 over 5. So that is what I've done. So see that 4 times 1 over 4 will give you 3. And this is 4 times 3 over 4 will give you 2 out of 2 raised to power 3. So 2 raised to power 5 times 1 over 5, that will also give you 2. So in all, you see that I'm going to have 3. 2 raised to power 3 is 8. 8 times 2 is 16. So my answer will be 3 over 16. Let's also look at the third one. The same idea. I want the negative exponent to be positive. So this is 216. So 1 over, because it's a numerator, so I want it to become a denominator. So 1 over 216 all raised to power 2, but the sign will change. Then I change the decimals also to fraction. So it comes 100. Sorry. This one should have been 16 over 100. That's problem over here. As I was saying, we want to change all the negative exponents to positive exponents for easy working, because as I said, it is not easy to work with negative exponents with that calculator. So this is 216, it is a numerator. So we want to change it to a denominator so that the exponents become positive. So this is 1 over 216 raised to power 2 over 3. So we see that this is 0.16. We want to change it to a fraction. So that will be 16 over 100 raised to power 3 over 2. But because we want the exponent to be positive, then the 16 over 100 should be 10 to become 100 over 16, so that the exponent will be positive over here. So you have 100 over 16 all raised to power 3 over 2, so that all the exponents are now positives. So we try to work this thing out using the third law. So we have 216, which is the same as 6 raised to power 3. We know that 100 is the same as 10 raised to power 2. 16 is the same as 4 raised to power 2. So this one, the 3 and the 2 over 3 will multiply to give you 6 raised to power 2. So you have 1 over 6 raised to power 2. That's this 10 raised to power 2, 4 raised to power, all is the same as 10 over 4 all raised to power 2. It is multiplied the 3 over 2. So the 2 and this one 2 will cancel it out. And then you are going to have 1 over 36, which is 6 times 6 is square, raised to power 10 raised to power 3, 10 over 4 all raised to power 3. So when you work this thing out, you are going to get 1000 over 36 times 64, because 10 raised to power 3 is 1000, 4 raised to power 3 is 64. And then when you do some calculations here, you are going to get 125 over 288. In summary, we have now got to know that when you have a over b all raised to power n, then it is the same as a raised to power n all over b raised to power n. You have also got to know that when you have a times b all raised to power n is the same as a raised to power n times b raised to power n. And we are also saying that anything raised to power 0 is equal to 1. And when you have any value like 1 over a raised to power n, the moment a denominator becomes a numerator, the exponent sign will change. And if it's a numerator and it becomes a denominator, the exponent sign will do what? Change. So the same application that you are using over here, you see that we have reciprocate. The a over b becomes b over a. So it means that the numerator has become denominator, and the denominator has become what? A numerator. In this case, the exponent should do what? The sign of the exponent should do what? Change. I hope you all understood. Thank you. Oh.
Last one.
Yeah. Try work. I want you to go home and then try and see if you can do this work on your leisure time. Try and do this work, and we will meet again next time. Thank you for. As I've said, this is my WhatsApp number. If you have any problem or any question, you can just put that on my WhatsApp page and then we discuss it. Thank you. See you again. Thank you. Bye. It's your Wadaada.